This is lesson 5.3, equations of parallel and perpendicular lines. We learned about these in previous lessons, and what we know is that parallel lines never intersect each other. Their equations have identical slopes and different y-intercepts. So if we had our y equals mx plus b, the m's have to be the same and the b's have to be different. The notation for parallel lines is two straight lines that never intersect. Perpendicular lines intersect at a 90-degree angle, so this is their notation. And their equations have slopes that are negative reciprocals of each other. It doesn't matter if the y-intercepts are the same or different for perpendicular lines. In this lesson, we're going to learn how to solve more complex equation problems with parallel and perpendicular lines. So first example, write the equation of a line that is parallel to 3x minus 2y equals 6 and goes through the point 4, negative 2. I've listed this out step by step of how we would solve this problem. We're given this in standard form, the equation's in standard form, so first we want to convert it to slope-intercept form. At this point, you should be comfortable with doing this, but we want to isolate for y. That would give us negative 3 plus 3 over 2x. So converting to slope-intercept form, we get this equation. Just a different way to represent the equation given to us that's a lot easier to work with. If we want to write the equation of a line that is parallel to this line, then that means they have to have the same slope. So for this new equation that we're writing, we know that the slope has to be 3 over 2 because it has to be the same slope of the equation given to us. Step 3, we're going to use the slope that we just found and the point given to us in the question to write out the equation of this line. Because it says again, this line that we're trying to write an equation for is parallel to this, so we got that down because we got the slopes to be the same, and it also goes through this point. So we can just write our equation in point-slope form using this point and using this slope. So it would be y minus 2 equals 3 over 2 x minus 4. So then our final equation will just get rid of that double negative. And here we go. So this right here is an equation of a line that's parallel to this line and goes through this point. Step 4 is optional depending on what the question's asking. Sometimes it might want you to write your final answer in a specific form. So this is in point slope form. Maybe it would want you to convert to either of the other two, and I've shown the steps here of how we do that. But again, you should be pretty comfortable with doing the conversions between the different forms at this point. Another example, write the equation of a line perpendicular to 4x plus 2y equals 7 that goes to the point negative 2, 5. We want to come up with this equation that matches these characteristics. So as always, our first step is to convert to slope-intercept form because this is way easier to work with than standard form. So we're going to get our y on its own. Now we have the equation in slope-intercept form. If we want to find the equation of a line that's perpendicular to this line, then it has to have a slope of 1/2, because 1/2 is the negative reciprocal of negative 2. So this new equation that we're writing has to have a negative reciprocal slope to the one that was given to us. And then again, like the last question, we're given a point. So we now know the slope and we know a point, so we can write the equation in point-slope form. So it would be y minus 5 equals the slope of 1/2 x, and again, this can be plus 2 because it's given as negative 2 here. So that's the equation of a line that's perpendicular to this line and goes through this point. And like the last question, step 4, we can convert to either slope-intercept form or standard form, depending on what the question's asking. You might be asked these types of questions given a graph. So given this graph, determine the equation of a line perpendicular to the graph that goes through the point negative 4, 1. So if something has to be perpendicular to this graph shown here, it has to have a negative reciprocal slope. So let's find the slope of the graph given to us and then kind of flip the fraction and change the sign. We know how to find the slope of a graph using our rise over run. So if we compare these 2 points, our rise is 2 and our run is 3. So the slope of this graph is 2/3. And if we want to find something perpendicular to it, then the perpendicular slope would have to be negative 3 over 2, because we flip the fraction and change the sign. So we know the slope, and we know that it also has to go through this specific point, so we can go ahead and write our point-slope form. It'd be y minus 1 equals -3/2 x plus 4. And I'm not going to show it this time, but again, we can always convert to either of the other two forms if the question's asking that. In our last example, find the equation of a line parallel to x minus 3y equals 8 with the same y-intercept as 3x plus 2y equals 6. So we've given two equations, and this new equation we're going to come up with has to share some of the characteristics of these lines. So the first step would be to convert both equations to slope-intercept form so we can easily work with them. So that's what I've done here. I converted the first one, and I've converted the second one. And once they're in slope-intercept form, it's very easy to pick up the slope and to pick up the y-intercept. So if we want this new line to be parallel to this one, it has to have the same slope. So it's parallel to the first line. It means they're identical slopes. So the slope has to be 1/3, has to match what you have here. And the second characteristic is that it has to have the same y-intercept as the second line here. So that means it has to share the same b value. So then b must be 6. So now we can put this together in our equation. This time it'll be slope-intercept form because that's what we're given. It would be y equals 1/3 x plus 6. So this now has the slope of the first line and the intercept of the second line. And as always, we can convert to another form if desired. We can't very easily convert to point slope form. It's very easy to convert out of point slope form. So that's why I said we just might convert it to standard form. We probably wouldn't convert to point slope form. So these are the types of more complex problems we can solve related to parallel and perpendicular lines.